Linked list. Okay, so linked list is an interesting topic and the easiest topic I would say in our data structures. So linked list is nothing but it's a kind of list. Okay, so there are types of linked lists. According to that, how many fields are there in this list will depend. So collection of nodes is nothing but your like linked list. Okay, we can say like that. They might ask represent. Linked list is a list is a collection of node where which has a pointer in itself which points to the next node. So let me first draw for let us start with single linked list. Okay, it is a collection of nodes, one node or more. It is a collection of one or more than one nodes in which one field has a data and another field acts as a pointer to the next node. Okay, so like that it is data. I mean definition you can just refer the nodes and understand. So main thing which I want to like explain single like linked list is nothing but you always have to like remember we use the concept of self-referential structure in which structure like a structure member will be a pointer to itself. That I like be explaining about self-referential structure in only the structure I mean structure video. So now let us see here, this is my one node. Okay, so here this will be my info and this will be my pointer. Pointer means it will hold the address of my next node. Okay, so suppose this node ka address was 200. So here that address will be there. Okay, and here again info. Let me take 3 nodes. Okay, then it should be simple and easy. So iska address was 300. Iska 100. I mean iska address 100. And here 300. Now this 300 should be here. And here some info will be there. Okay. Now here what will be there? Here null. Because there is no another this what to say field. So see here, this address info link, this pointer holds the address of next this list. Okay, suppose here info is there, whatever info you want through the user input, or you can declare static allocation of memory, like statically you can give values. So suppose this was having some value, suppose 6, and this was having suppose some value and 12, and here suppose that value was 4. Okay, so like this, as you can see here, this is node. Okay, this we say as in how we represent this thing, we represent as node of info. Why am I using node is because I have called I call this as node. You can give anything. Okay, you can either give SLL. Okay, SLL is not single linked list, and you can give anything. List of info, LL also, one letter also you can give. So this thing all depends on us. The user should give this. Here also, why I am giving info, because I had declared, like suppose in my code I had declared like info. So this is my node of info, and this thing we call as node of next. This line, okay, both are same. This I say as node of next. So my this next is nothing but the pointer which holds the address of second list, not second, next node. Okay, this next is nothing but a pointer. It is a pointer. Okay, so it holds the address of the next node. So this is the basic thing you have to remember about linked list. So now I'll say one thing. Suppose I want to create a linked list. Okay, I want to create a node. I mean node. There is no node present. For time being, say you can say it's not there. So I created this node. So what you have to remember in mind is, whenever you create a node, every time, each and every time, if you create a node, you are creating a new node, which means in simple terms, suppose, okay, this is your storage place of whatever you manufacture, and this is the place where you create manufacture. Now you see here, whatever you create, you will put here. Okay, simply just one example I am giving. So whatever you create, you have put here. Okay, and it will be connected somehow. But whatever you are creating here, that will be single itself. Understood? So it will be a single piece alone itself. It will always be only one thing. So like that only, whenever you create a node, it will always be one node itself, and it won't be having any other nodes. So whenever you write a node, so first you using dynamic memory allocation, you will create a node. Then what you say, this node of info, right? Node of info is equals to info I will write, okay, or else let me say item, int item, or else okay, node of info is equals to info only like that. If it is same, it will be easy to write, because what is this, what is there here should be same here, okay. So here info will go, then node of next, this node of next also I have to write, is equals to null I have to write, okay. Always remember, whenever you create a new node, this field should be null, okay. Now we will see how we create a node. So this thing you keep in mind. So I will write void create. This is just basic thing to write. Now I will write node star new node is equals to, okay. Why I am writing this? This comes under self-referential structure. If you have seen self-referential structure, it shouldn't be like difficult for you. Since I am using self-referential structure, now here also I can write void here also node star. Now then create also I can write, okay. This we will see it later. Simply you keep as this. While explaining self-referential structure, I will explain that part. Okay, node star new node is equals to, here again. So dynamic. So we will use malloc dynamic memory allocation function to use it. So first thing what we will write, we will write this node with star. Then I will write malloc, malloc, malloc. Then I can open the bracket, size of. After size of, again open bracket. Here again I will write node. Whatever size I have to give, I will write that, and again I will close. So here is capital. So okay, let me write it again. First I wrote write node with the star, then malloc. What is there here? Same thing will be here also, okay. Size of, here node will be there. Here star won't come, okay. Then close. This same thing I have written here. Whatever is there here, it will be followed by a star. Same thing will be written here without star. Okay, usually how you create struct student this new node is equals to, like this we will write. Instead of writing struct student everything, I created a type ID, so which is used in type def structure. Okay, in type def structure we can create a type ID where only this one word is necessary required to write, remaining thing you can do like this. Okay, so I from this now my node is created, okay. From this my node created. Now what I will write, new node I have given name, okay. New node, here I can give anything, okay. I will just give new. If I give new, here only new of info is equals to info. Now what will come here? So usually in main function what we do, in main function we give, right, enter the item or enter the data to be inserted in the list. Then we'll write scanf percentage d info, like that. I mean ampersand info, like that we'll put. So whatever we write here, it will come. This is only create now, so it like this. So we have to write a printf and scanf statement in the main function to take that this. So there inside that thing this will be given. I will show that also, but not now, but later. Then new of next is equals to null I have to write. Now we hurried here, okay. So we wrote about creating. So we understood what, how this here, this info, this next which will be null. Usually first I will write you that type structure. So okay, let me let me show you how this structure is like declared. So I will write struct is necessary, type def, okay. Type def struct and node here, okay. I will write like this, node, type def struct node. So here what will be there, under this type def struct node we did. Now we will declare the member, okay. Int here info, okay. Then int info, only info. Suppose only one single linked list, right, you want to write info. Suppose it was a linked list using single list as employee data, then you had to write int char name, char phone number, everything so on. But here we need only one thing for understand. So int info, right. Now see here self-referential structure we have to write. So again what we have to do here, we have to write struct node okay, star, here next, okay, then I will close here like this, then again I will write here node. So this is my type ID. So whenever I want to access this structure, I can simply write this node, I mean this data member. Okay, whenever I want to access the data member, I can simply write node star, and I can write the thing name of that particular function or variable to use. So that's why I was using only node. Okay, this is the way of declaring this type def structure. You can see the nodes once if it is correct or not, but usually what we write a struct student, then something, again we give name struct student, and then if you want to access struct student, again one thing you have to declare variable name. That is a big thing. Usually that takes more of your space. So here only two things will be extra, but whenever you want to access structure, we can only use this type ID as node. Like this you can write, and you can access here node new node, new if I write, how I wrote. So that this thing will be declared, okay. This memory space will be given to that place, then I can dynamically allocate memory for that, how much ever is required. Then I can simply write. So you saw right what I wrote. I created a new variable, new as thing, new of info. So here this info, it is accessed by this, where there we didn't declare, right? Why we didn't declare? Because already we had defined this structure thing of our list here. Then new of next. See, this thing was accessed here. This here, this will be info, and this will be your null. Okay. Now what we have to do? So we created a node. Now we have to see insertion of a node. Okay, insert front. So suppose first thing, if you want to insert a node where at the front or at the end, you have to first check the condition if your list whether it is full or I mean if it is empty. If your list is empty, right? If there is no list, is like this, it's nothing list. So what will happen? So my new created node was new, right? So new was my node which is created. Okay, this is the node which I created. If it is like if there is no list present, so what I will do? Yeah, main thing here we declare a pointer. We will say okay, head equals to star here tail, okay, equals to that's all. Yeah, null. Head and tail I am declaring equals to null, and initially this head, okay, so this one global declaration, it won't come under any function, it will be declared globally. So now linked list. So if it is empty, now what will happen? If I will check a condition, if my head, okay, head equals to null. If my head is null, what does this statement mean? That there is no list present. Okay. So what I will write in this block of code? I will write my new, okay, new of next is equals to head. Okay. First what I made, my node will having, right. So this here some info is there. This next address I am pointing towards the head. So this next address I made as head. Okay. So then what I will do? Here head is equals to new. Okay. So better first let me write like this, new equals to head. Okay, I will write only like this because I will make this new node as head node itself. New equals to head equals to, I will write tail for first thing. Then what I will write, new of that's it, that much, this much line is enough. Okay, because why means we have already declared new of next equals to null in that create part. So here we only have to declare head equals to tail, which is equals to this new node. Okay, then what we will say, we will check for another condition, else if, else, sorry, if. Here what we will check, we will check only one node is present or not. How we will check that? Head of next is equals to null. So see here, this became a head, right, from this statement. Again I call this function. So suppose there was empty, I called the function, this happened. Again if I call, this is already one present, right. So this condition will check. Head of next is null only, right. This is null only, right. So if it is null, which means only one node is present. Okay. So what I will do? Head of next is equals to new, I will write. Here head equals to new is there. Here head of next equals to new. So only this much thing you will write. Anyhow, new of next is null, we have already declared. So head of next equals to new. Okay. Then if you want head of next equals to new, or else better, instead of head, what we will do, we will use tail of next. Okay. Since we declare this, even tail will be here, right? So why I'll say this, do this, it is the best way of writing like understanding single linked list. Though head and tail are required for a doubly linked list, but I am using this in single linked list. Why? Because here, see here, my head, so here this was my list, okay, this list. So my head was here and my tail was here. Okay, so what I did, tail of next I made as my new node. Okay, so tail of next equals to new node. Then here new equals to tail I will write off. Okay, new equals to tail. Then what I tail of next is a new node. I gave this what to say, attachment. Here you can write head also, tail also, just giving a connection here. Okay, then I will write new equals to tail. So my tail, it was here, now it will become here. Understood? And this will be null itself automatically, but that we have already declared in the create function. So see here, my head remained in the same place, but my tail shifted at the end part. Now what you can do now, here why this now, whenever you create insert a node, this was insertion at the end. Okay, this was insertion at the end. So whenever you create a node, I want to insert at the end, directly you can say tail of next. You can add the tail of next again if you want to insert at the end. So you can use this tail. Tail will always be at the last. Okay, so tail will always be at the last. You can use this tail of next equals to new. So this word term can be used again and again to insert a node at the last. Now same thing. Okay, same thing if you want to write. Let me erase this. So to insert at the last, I will say tail of next equals to last. See here, tail of next equals to new. Okay, then what I will say, new equals to tail again. So now I will show this diagram again. So this two was there, I inserted new. So this was my head, head of next, this was my tail. So first statement for the tail of next equals to new. So my new attached here. Then what I do, new equals to tail. So my tail is here now. This is obviously it is null. Okay. So see here, whenever I do like this, whenever I want to add, simply I will do like this, tail of next equals to new. Again one more node will be added here, and then you go like that. So this is for my end insertion. Okay, now I will do front insertion. Suppose this is my tail here and this is my head here. Okay, HEAD, head. Now I want to, I call the create function. First I will call the create function. Now I want to provide connection like this to this at this beginning of the list. So what I will do, this is my new, right? So this is my new. What I will write, new of next equals to head. Okay, this next equals to head I write. So I provide a connection. Now this new node is connected to head, but I want to make this should be my first node, right? So what I will do, this should be first. So head new equals to head I can write, or head equals to new. Both are same. So my head was here, it will now go to this part. Okay, so this is a basic thing. Now like this, similarly insertion over, right? This is how you insert, but while inserting you have to always check, in insert end you have to check if head equals to null, head itself is null, then no nodes. Okay, if head of next equals to null, only one node. Okay, or else then else part I will write, else I will simply directly I will write off this end insert for whatever insert big I will write, insert beginning. For insert beginning what I will write, new of next equals to head, then new equals to head. Now end insertion, how it will be, insert, what happen, tail of next equals to new. Okay, tail equals to new. This much thing you have to remember. Okay, everything is same. This thing you will write, do same. If it is inserted at the beginning function, you will write only this part of code. If it is inserted at the end function, you will write this instead of this. So this is what about your linked list. What is that, insertion. Now deletion. Okay, suppose there are nodes like this. Okay, so this will be my head usually and this will be my tail, we knew that. Okay, this won't be having any name. Okay, so now what I have to do, if I want to delete, first before deleting I will again check if it is empty or not. If it is empty, then no need to delete. Okay, again first I will check same thing, right? If head equals to null, means no nodes. Okay, then just write over the bracket. If you want to write a printf anything, you have to put there. Okay, that thing you have to see in the code and write. If head of next equals to null. Okay, so here what you have to do, this means only one node. If I want to delete and I know only one node is there, so what I will do, directly I will write free of head. Directly I will delete that free of head. Okay, then what I will do, head equals to tail equals to null. This much part you just see and write. I will in like this it will come. Okay, this else part will start here. I mean if part. Okay, again else if here, then else if yeah. So one more part which is left is your more than one nodes ka part. Yes, you understood, right? If there is no, if head is null, then no node is present. You write nothing. No, list is empty and we cannot delete anything. If head of next equals to null, else if head of next equals only one node is there, so directly that free head I will do, head equals to tail equals to null. Now suppose more this else part now at the end. So like here more than one node is there, only else I will write. Else if over last part else. So else what I will do, I will create a temp variable here. Okay, how that node temp like this I will create equals to head. So this is the deletion at the end. Okay, so node temp equals to head. Now you see here what I will do here for now from this statement. Now my head is here, right? Even my temp is here now. Okay, so now what I will do, see here a very easy and interesting. So now my temp is here, my head is, so this node here, this node I can say temp of next is this node, right? So temp of next equals to, so see temp of next is this node is equals to head I will do of. Okay, temp of next equals to head. So what happened, head was here, now my head will be here. Then what I will do, I will call this free of temp I will do. Okay, free of temp I will do over. So then this code will get over, that's it. So this thing got deleted. Understood? So this is what you have to write for deletion at the beginning. Okay, suppose you want to delete here. Okay, now let me take the same example again. I will write, you want to delete, my head is here. Okay, this last node. So what I will do now, let me write it a little bit short over here. So else part, again same thing itself here. I will write node star temp equals to head. If it was W linked list, then we don't have to use while loop over here, but now we will have to use while loop to now my temp is here, right? My temp is here. So what I have to do, I have to take my temp to this place, last second place. So better to understand that even easily. So you have to understand properly, right? I will take like this. So my head was here. Suppose 4 nodes are there. From this statement, my temp is also here now. Okay. So my temp is here, my head is here. Now what I have to do, I will write while loop, while temp of next, okay, is not equals to tail. While my temp of next is not equals to tail, what I will do, temp equals to temp of next. Okay. So here temp equals to temp of if temp of next, so temp of next what is this? Is it tail? No. So what will happen? Temp equals to temp of next. So my temp, it is this now. My temp will come here. Okay. Now again it will check temp of next. So see here, temp of next is not equals to tail. Is it tail? No, it is not equals to tail. Now what will happen? Temp equals to temp of next. So my temp, it will jump here now. Temp. Okay. Now again you see here, temp of next is not equal to tail. Temp of next is my tail now. Okay. Is it true? So it will come out of the loop. Now as you can see here, I wanted to bring my temp in the last second one. Why I wanted to bring is because now see here, now how I will delete. I will delete this node. So what I will do? Either two things you can write. Now free, I will write whatever you can. Either I can write temp of next. Okay, I can write this, or else I can write free tail. This is easy, right? Free tail I will do. So let us go with this free tail. Both are same. Temp of next I can delete this node, or else free tail also same thing will happen. Free tail. Okay. Then what I have to do? See, tail is deleted, but I want to declare my tail as this, right? So now free tail I did off. Okay. Now I have to write temp of next is equals to null. I have to write. Why? Because previously this was having some address, suppose 30. So 30 was stored here. Now if I don't declare as null, 30 will simply be there here. It is a garbage value type. So temp of next should be null. Then I will write tail equals to temp. Okay. So again, if you call the function, see now my temp was here, but if you call the function again, from what is the first line saying? Node temp equals to head. Okay. So this will go here, or else better thing, you don't write this node star temp equals to head. You write in the beginning of the function. Okay. So you write delete, right, void delete, like that. So here only you give this statement. No, this statement like here. Okay. Then this won't be required to write here. It will be globally declared. So again, as soon as you come finish, directly globally it will initialize temp equals to this. Anyhow, both are fine. So anything is fine. Yeah, now you understood, right, how we delete. So this is over. Now I will do for display. Only display is left. Okay. So this is tail. Again I will write for display node star temp equals to head. So my temp is here now. So what I will do? I will write while loop again. I have to display the info of each node, and then I have to traverse till the last node. So for this what I will do? While temp of next. In deletion what we did, not equals to tail we wrote, right? Here or not equals to null I will write. So this part is null right here. So I want to bring my temp till the last place. Okay. Then open the bracket. First what I will do? Printf statement. You write full %d I will write. Here temp of info I will write. Okay. First I am displaying. See here. Before traversing my temp to this place, what I am doing? First I am displaying the content of temp, content of head. Then what I will do? Temp equals to temp of next. Okay. This while loop is over. So now what will happen? First thing, temp of next is not equal to null, true. What will do? It will display first this. It will display this. Then it will go here. Again, it is not next is this is null. No. Now it will display. It will go here. One thing. So just listen here. Important thing will come now. So again, temp is here. Temp of next is null. No. Okay. It will display this first. It will go here. Now you see here. Now temp of next is null. Okay. Since temp of next is null, it will come out of the loop itself. But we didn't print itself this info. So what I have to do? Again I have to write again printf %d. I can either I can write temp of info itself again, or I can write tail of info also. Understood? So this is the code you have to write for displaying the temp. Okay. Suppose you want to delete all the temps, I mean nodes. So here instead of this, what you do? You can give free function in the middle, free temp, or like that. You can one by one you can give free temp. Temp of temp equals to temp of next, free temp, or else one by one you traverse, right? Two things you will be like using. Anyhow, so one by one you can delete each and every node. So for displaying, this is the part of code, right? So this complete your singly linked list. So I hope you understood. It was quite lengthy, but still completely this part was explained here. Okay, at the beginning it was a bit boring. I accept that small thing. So even my whatever I knew, it was like refreshing at that time. So easily in the easy terms, now I explained you everything. So I hope you understood.